Okay, so we're going to be looking at the graphs of the 12 basic functions today, and we're going to look at their key features, so all the stuff that we talked about in the past 2 days. So the first one we're going to look at is called the identity function. Think about it as being like linear function. So this is our identity function is what it's called. So the equation for it is f of x equals x. So f of x equals x is our equation for our identity function. Okay, so some of the properties that we want to look at. So this is going to be, so we want to look at and see if it's continuous or discontinuous. So because we can run our finger across the graph and never stop, this is going to be a continuous function. Okay, next thing I want to talk about is if it's odd, even, or neither. So odd functions were symmetric about the origin. Well, this is symmetric about the origin, so this is going to be an odd function. Another way to tell what kind of function it's going to be, if we remember the test for odd, even, or neither, if you plug in negative x here, so if we do f of negative x, you would end up with negative x, which is the opposite of what we started out with. Okay. Other things we want to talk about is the domain. Okay, so domain, remember, is the x values. So you can plug in any x value here and it will work. Okay, remember there's no square roots or anything here. So this graph shows our domain is negative infinity to positive infinity, all real numbers. And so same thing, if we look at the range, so the range is the y values. Well, since you can plug in any x value, it could be any y value, and it shows here there's no restrictions on the y. So the range is also negative infinity to positive infinity. Okay, so this is it's called the identity function. It's just a line, y equals x. It's odd because it is symmetric about the origin. It's continuous, there's no holes or asymptotes. And the domain and range are both all real numbers. Okay, so the next one that we're going to take a look at is called the squaring function. And the equation for the squaring function is f of x equals x squared. So you think about this as being a quadratic. And let's go back, let's put here linear. You hear those terms, and you also hear quadratic here. Okay. Alright, so thinking about it's a quadratic. So we want to see if it's continuous. So there are no holes or no asymptotes here, so it is continuous. So even, odd, or neither. So remember, odd we said on the first one was symmetric about the origin. Well, even is symmetric about the y-axis. Well, here's the y-axis. And you can see it is symmetric about the y-axis. So this is an even function. Also, if we did the test, if you were to plug in negative x, because it would be negative x squared, you would end up with the same thing that you started with. So that makes it be even as well. Alright, domain and range. So looking at the domain, or our x values. So if you look at it algebraically, there's no square roots, no fraction. So you should be able to plug in any number. And then the graph just confirms that. So going through the x values here, any number could be plugged in because it goes from here to here. So domain is all real numbers. But the range, so the range is the y value. So for the range here, the first y value that it is 0. But then from there, it can be any other y value. It can be any y value above that. So it can be 0, so we're going to do 0 to infinity. And because 0 is included, 0 is going to get a bracket, but infinity gets a parentheses. Okay, so that's your squaring function, or as you probably know it more, a quadratic. Okay, so next we're going to look at the cubing function. And a lot of times you'll just hear that's a cubic. Okay. The equation for it is f of x equals x to the third power. Okay, so this graph is going to be continuous because there's no holes or no asymptotes. So next we want to figure out if it's odd, even, or neither. So this is symmetric about the origin. So because it's symmetric about the origin, it's going to be odd. And then if you were to do the algebraic test, if we were to plug in a negative x here, well, negative x to the third will make it stay negative. So it will be the opposite that you started with, so which makes it odd. Okay, domain. So domain, we're talking about the x values. So for the x values, this can be any x value. If you look at it algebraically, there are no square roots or fractions. So domain can be all real numbers. And then for the range, we're looking at y values. So if you go up the y-axis, it can be any y value because it can be small values or large values. So this will also be negative infinity to positive infinity. Okay? So then we're going to look at what's called the reciprocal function. And this is f of x equals 1 over x. Okay, so a couple things here. So first thing is it's continuous. Well, if you were to run your finger across this, you'd have to pick up your pencil to move it to the next one. So it's not going to be continuous. So we'll say discontinuous. And what's going on here is we have a horizontal asymptote and we have a vertical asymptote. And just to talk about what we talked about a couple days ago, so to figure this out, if you wanted to graph this by hand, you couldn't do any factoring here. So because that x is left over there, that's why you have a vertical asymptote at x equals 0. And then remember, for the horizontal asymptote, you look at the degree. Well, it's small degree over large degree. But when you have small over large, that's always y equals 0. And that is true to our graph here. We have the vertical asymptote and the horizontal asymptote both at 0. So it comes from that equation. Okay, so remember for discontinuity, we either had removable or non-removable. So because this is an asymptote here, then it's going to be non-removable. Remember, only holes were the removable type. So non-removable discontinuity. Okay, for odd, even, or neither. So for this one, it is symmetric about the origin. These are flipped over each other. Or algebraically, if you were to plug in a negative x there, it would stay the negative x. So it would be the opposite. So this is odd. Okay, so for the domain, okay, so domain are x value. So remember algebraically, we talked about the domain, you can't have 0 in the denominator. So x could not be equal to 0. Okay, so because x can't be equal to 0, it can be anything but 0. So the domain would have to be negative infinity to 0, union 0 to infinity. So let's take a look at that on the graph. So by the graph, it can be any x value here, but then the x value 0, it can't be, and it can be any other x value here. So that makes sense with that. And then for our range, so we're just going to use the graph here. So if we're using our y-axis, you start here, it can be small values, but then it stops. It can't be anything at that horizontal asymptote 0. Then it can be anything bigger. So it can be anything but 0 because of the horizontal asymptote. So from negative infinity to 0, union 0 to infinity. Okay, so for the domain and range, 0 is excluded because of these horizontal and vertical asymptotes. Okay, so then we're going to look at the square root function. So for the square root function, this is f of x is the square root of x. Okay, so to figure out if it's continuous, so it is continuous here. I know it doesn't go down here, but with what the graph you have, it is continuous. No holes or no asymptotes. So odd, even, or neither. So this is going to be neither because it's not going to be symmetric about the y-axis and it's not symmetric about the origin. Also, if you were to do the test, you can't plug in a negative under the square root, so it can't pass the test. So that's going to be neither odd nor even, so I'm just not going to write on there. Okay, so for the domain, so remember if it's under the square root for the domain, that means it has to be whatever is under the domain, or sorry, under the square root has to be greater than or equal to 0, so x has to be greater than or equal to 0. Well, if you look at your graph here, the x values start at 0, because they can't be over here, and then they keep getting bigger. So it can be 0 or it can be bigger. 0 is included, so 0 is going to get a bracket, so from 0 to infinity. And then for our range, so the range, we're just going to look at the graph here. So for the range, it can start at a y value of 0, and it can be anything larger than that. So it's going to be just like the domain, from 0 with a bracket to infinity. Okay, and then we have the exponential function, which is f of x equals e to the x, and we've kind of already mentioned this a few times. So some things about this function: it does have a horizontal asymptote at y equals 0. Okay, so this exponential does have a horizontal asymptote at y equals 0. So we have the horizontal asymptote there. So we want to figure out if it's continuous. It is continuous. So even, odd, or neither. So it is not symmetric around the y-axis, and it's also not symmetric around the origin. So it's going to be neither. Then we're going to look at our domain. So our domain are our x values. So for our x values, if we're going along this line here, the domain, it could be any x values. Any x values will work. So from negative infinity to positive infinity. And then for the range, we're looking at y values. So for the y values, if you notice, there are no y values here under 0. And the y value also can't be 0 because we have a horizontal asymptote. So it can be anything bigger than 0, though. So when we're going to write this, because it could be like 0.1 or something, it could be 0.0000, it could be really close to 0, but it's not going to be 0. So we're going to write that from 0 to infinity, but 0 gets a parenthesis this time because of that horizontal asymptote there.